Vocabulary word cards ready for us to use today. We're on page 294, using theorems to determine unknown measures. You'll get a lot of practice on this with your online work, but we're going to talk about at least some examples that you can use here. So you can use this video as a resource for that. To be ready for this video as well, we're adding to our stack of cards. So find Congruent Supplement Theorem. We're going to put some information on the back of it. I'll share with you what that is. Have right angle congruence. And excuse me while I find that card that slipped. Right angle congruence, we're going to add to this one today as well. And then the last one, vertical angle theorem, which we just did in video on page 293, page 292. Go find those, go watch those. If you haven't done those videos yet, you need to. We build on everything on a video by video basis, so we'll take a look at it. Let me go ahead and resize this window so that you can see more of the book and less of me. Let's get into this one. Page 294, have a highlighter, have something to write with, and let's acknowledge the habits of mind. We're going to reason abstractly and quantitatively. A lot of quantitative in this actual activity. We're going to construct viable arguments and critique the reasoning of others for another thing that we're going to do as mathematicians. Using theorems to determine unknown measures. It's an algebra skill that we're working on. Let's add to the note cards though. Let's see here. Right angle congruence postulate. So I see that that's actually on this page, page 294. So I'm going to jot that on the back of this. And then I'm going to put what it says. All right angles are, all right angles are congruent? For sure. All right angles are congruent. Now that's obviously true because if you have a right angle, so there's my right angle, it's the corner of a box, and I have another right angle, corner of a piece of paper, because that creates it. Those are 90 degrees and 90 degrees. And so therefore 90 plus 90 and 90 are the same. So yeah, all right angles are congruent. We have to say this? We do. Congruent Supplements Theorem. So Congruent Supplements Theorem is from page 291, but we're also mentioning it now on page 294. So on the back of the card, let's go ahead and have the definition. Let's have an example. And let's put the page numbers where you're able to find it. Okay, then we have vertical angle theorem. Vertical angle theorem says vertical angles are congruent. We did that on page 293. And we're doing this again on page 294. Every time that we reference a vocabulary word and it's specifically mentioned somewhere in the book, we should start keeping track of it. Okay, number one. In the figure shown, line AB intersects line CD at point E, and we're going to determine the measure of angle AED. And I think if I put my face over here, and then slide the book more that way. Yeah, perfect. Okay, let's go. So, got to find it, right? We got to find AED in the problem. AED is this angle right there. We have to know what its measurement is. The nice thing with this problem and setups like this is that angle AEC and angle DEB, those two angles, they're vertical angles. So because they're vertical angles, they have to be congruent. We're using the vertical angle theorem to say this step. X plus 94 equals 4x plus 25. We're going to solve that equation. So depending on when you saw solving equations last, it could have been in this class's review, it could have been in 8th grade, it could have been Algebra 1, whenever you had that. We're going to get x by itself, and we're going to figure out the measurement of our angle. So step one, I have x on the left side of the equal sign, and I kind of like drawing, maybe like with like a different color. I like making sure that I separate left side, right side. The more equations you solve, the less you need to write this line. But until you're good at solving equations, you've got to make sure you maintain left side, right side balance. I have 1x. In fact, it's not written, but there's always a 1 in front of the variable unless it's a different number like 4. I have a single x over here. I have 4 x's on the right side of the equation. Let's take away the smallest number of x's. Minus 1x, minus 1x. That's a subtraction property. If I can find subtraction quickly enough. Oh, I swear I had it. Substitution, that's not it. Okay, 1x minus 1x makes 0. But there's still a 94, so 0 plus 94 is the left side of the equation. And then 4x minus 1x makes 3x plus 25. We need to get a single x by itself. So in order to do that, now we look at the side where there's a 3x and a plus 25, and this is the side that's complicated. We want x to be by itself. We don't want x in two sides of the equation. We want it on one side, and then we want no other numbers next to it. So the next step is to use subtraction property of equality, and we'll subtract 25. Subtract 25. So 25 minus 25 becomes 0. It's canceled. We're left with 3x. There's still a 3x over here, equal sign on the dividing line. Keep the equal sign present and visible. Now we got to do 94 minus 25. 95 minus 25 is 70. So 94 is 1 less than 95. So 69 is the subtraction of 94 minus 25. Divide by 3. X equals 23. Now you might say, I'm done. I solved it. It's over. No, that's not true, because you have to take that 23. That's not an angle measure. It's just how big this unknown variable is. You got to take the 23 and you got to replace or substitute x with 23. So we can do that in either of these two problems. We can do 23 where that x is, or we can do 23 where the other x is. It will still matter. It'll still be the same. You get the same answer. X is now that number because we solved it. Now solving it, plugging it in, 23 plus 94 makes 117. This is a 117 degree angle. You know what? So is the other side because they're vertical angles. Now, in order to figure out what angle AED is, this whole pair of angles forms a line, which means it adds to 180. So I'm going to take 180, which will equal 117 plus the measure of angle AED. We don't know what this measurement is, but I know that when I add it with 117, together those two angles make a line. So then therefore they have to add to 180 degrees. By subtracting both sides by 117, I get the following answer: 63 equals the measurement of angle AED. This is the final answer. I used linear pair, I used vertical angles, and I used supplements. Supplementary angles add to 180. Let's do question 2. In the figure shown, line PQ intersects line SR at point T. There it is. It said so. You can see the picture. You can read the sentence. It does. Determine each angle measure. So the angles that we need to figure out, we need to figure out how big X is, then how big Y is, and then how big Z is. So let's start off by understanding that this angle with the expression 3x plus 4 and this angle with the expression x plus 24, together those add up to make a straight line. Angle PTR plus angle PTS. Those two angles together. In fact, this is how we should write it out. The measure of angle PTR plus the measure of angle PTS equals 180 degrees. That's because they form a linear pair, and a linear pair of angles are supplementary, right? Linear pair means that those angles add up to 180 degrees. So we can use substitution to replace 3x plus 4 with angle PTR. So a substitution step lets us put 3x plus 4 right there. And then angle PTS we're going to replace with its algebra expression, x plus 24. Still equals 180 degrees. Degree there, degree there, degree there. So since that's the situation that we have here, now we solve the equation. We got to figure out how big x is. So left side, right side of the equal sign. Again, you don't have to add that dividing line if you understand the whole equal like structure. Okay. Now, combine like terms, which isn't a note card word, but it probably should be, or you should remember from when you solved equations in the past. Combine like terms. There's a 3x on this group of parentheses, and there's a single x, technically it's a 1x right there, and when they're on the same side of the equal sign, over here on the left side, when they're on the same side of the equal sign, we add them together. We don't cancel, we don't do the opposite, we just bring them together. So 3 plus 1 makes 4x. And I like to draw like a little like connecting arrow, like they're coming together. 4 plus 24, those don't have x's next to them, so they're like terms, they're similar terms. They're not variables, they're just numbers, 4 and 24, which is different than 3x and 1x. That's how many variables are together. 4 plus 24 makes 28, equals 180. And again, we're bringing the 4 and the 24 combined like terms with a plus sign between them. Don't forget the plus sign, students do. That's wrong. 4x plus 28 equals 180. Solve for x. So at this stage of the game, you should know, I'll say it and then I'll just write to the answer. Subtract 28 from both sides, so you have 180 minus 28, and then you'd be left with 4x equals, what is the result of that? 180 minus 28 is 152. Then you divide by 4. So x equals, there's a dot, dot, dot. You do the subtract 28, you do the divide by 4. When you're done, you get x equals, checking my notes, 38. Okay, that's part one of the things we need to know. The second thing we need to know is that if x is 38, then we should go back to our equations, our expressions, I mean, and we should plug in, using substitution, plug in a 38 right there, and plug in a 38 right there. So this becomes 38 plus 24, and this one becomes 3 times 38 plus 4. The nice thing about vertical angles, again, you should have the note card, and vertical angles lets us know that these two angles are the same. And these two angles, highlight pink, highlight yellow, these two angles are the same. And it's on the wall behind me, but I'm going to see if I can find it relatively quickly. When two angles form a straight line, a linear pair, they add to 180. So actually, technically, I'm going to just pick the easiest expression, 38 plus 24, and I'm going to solve that one. Z equals, that's a Z, 38 plus 24. That Z is making me mad. You can't even see it. My face is in the way. So if I do 38 plus 24, I will have the angle across from x plus 24. 38 plus 24 is 70, it's 62. Angle Z is 62 degrees. 180 minus 62, again, using the linear pair postulate that says that two angles have to add up to 180. So if this is a 62 degree angle right here, see on the side of the screen, sorry, it's way over there. If this is a 62 degree angle, then angle Y will be the rest of the numbers necessary so that these two angles add to 180. I'm not going to bother with this expression. I mean, you could. 3 times 38 plus 4 is how much? But I can also do 180 minus 62. So I can say right here, Y equals 180 minus 62. And for that, I get an answer of 118. There you have it. That is all of activity 5. We have used our vocabulary words. We solved some equations. Box your numbers, box it there, box that there, and we've answered all of the angles. Thank you for watching this video. Thank you for checking in on activity 5. We're going to do talk the talk on page 265, and then, wrap up lesson 1. Again, thanks for watching. Thanks for continuing your journey, and I'll see you in the next video.